Alright class, so in this final video we're going to look at graphing quadratic equations. So first let's just look at our basic quadratic formula, that's what we call just a parabola. This is y equals x squared, okay, and this could be shifted, but here's just our very basic parabola, y equals x squared. So anytime we're graphing something for the first time, we don't know what its shape is, let's just plug in values and see what we get. So we'll create a little chart here. We've got x on the left hand side and y which equals x squared on the other side. So for x equals -2, we end up with 4. So -2 squared is 4. -1 for x is just 1. -1 squared is 1. 0 squared is 0. 1 squared is 1. X equals 2. 2 squared is 4. Okay? So let's create a little graph for this and just plug in our numbers. Plug in the numbers that we got over here. So we got x equals -2, y equals 4. -2, 4, good. X equals -1, 1. -1, y equals 1, good. And so on and so forth. And then we just connect a line between those guys, okay? You'll see I sort of rounded it. You may have been, wanted to put it as a straight line, but what you see is that this is a very curved, this is a curved line. It's not a straight line like we've been seeing in the past. This has got a nice curvature to it. So if you were to plot more values, that'd be more and more clear. Okay? Good. Let's look at a slightly more complicated equation. Y equals 4 minus x squared. Okay, again, let's just create a little chart here. I'll plug in these numbers and allow you to, fill in those values on your own, but you can see them there. So where y just equals this 4 minus x squared. And here I've got the graph plus the numbers charted out. And here's the line, okay? So let's look at this really quickly. Let's just take the opportunity to see how this equation has changed, okay? So by adding this negative value in front of the x squared, what we've done is now flipped our parabola upside down, okay? The other thing that we've done here is by adding this 4 out front, we've shifted the vertex, this point where it turns around, up 4 points, okay? So where we just had y equals x squared, positive x squared, we had a parabola that looked like this, looked like a U kind of, and its vertex was right at 0, okay? By adding this 4 to it, we shift the vertex up 4, and adding the negative value in front of the x squared, we flip it upside down, okay? So just little tricks to start keeping in the back of your mind so you can see how, it'll make it easier for you later so you can do less of this pointing, doing point by point. Okay, now let's find the vertex and intercepts for these equations. So here's just a general equation, a general parabolic equation. So the first thing we want to find is that, here's the vertex. It's this minimum value or maximum. It's this point where it turns around. So if this was upside down, the vertex would be the maximum value. If it's this way, it's the minimum value. The intercepts are where our equation crosses the y-axis. So for this, we'll see it in the next slide a little bit, but this is where y equals 0, okay? So we end up with an equation like x squared plus, like x squared plus x plus c equals 0, which is exactly what we were solving in the previous equations, okay? Or in the previous video. So that's just solving a quadratic equation. So the intercepts occur at the roots of this equation, where the roots are where y equals 0. In other words, it's where x equals minus b plus or minus b squared minus 4ac all over 2. Oops, and this should be 2a, sorry. Okay, so just the same things that we were doing before. Okay, that's where our intercepts are. Our vertex, we could solve it, but I'm not gonna bother showing you this. Our vertex occurs when x equals minus b over 2a. Okay, so now we can use this information to make our life a little bit easier solving these equations. Instead of doing it point by point, let's just find a couple of these points and plug it away. Okay, so here we've got an equation, y equals negative x squared minus x plus 2. Excuse me. Now let's solve this by finding our vertex and intercept values. Okay, so I do want to make a quick little note here. At this point, your book starts to make a little change in notation. It starts, instead of exclusively showing equations as y equals negative x squared or something like this, you're going to actually start seeing this as f of x, where f means a function. So we've got some function of x. We don't care so much about calling it y, for example. So if you start seeing this, just know that you can basically consider it the same thing as y. Okay, so the first thing, let's find the vertex, which our equation was negative b over 2a. We've got b is negative 1, a is negative 1, so we just plug those values in. We get that our x value is equal to negative 1/2. So now we want to find out where's that y value for that point. So we know the x value now. So now let's find the y value, or the f of x, at x equals negative 1/2. So just plugging that into this equation up here, we get y equals 9/4. Okay? So now we've got an x value and a corresponding y value for the vertex. We've got 1 point now. Now let's find the intercepts, where it crosses the y-axis. So here's our, it's when y equals 0, right? So we've got negative x squared minus x plus 2 equals 0. I'm going to divide both sides by negative 1 just to pretty it up. It doesn't really matter, but I don't like having negative numbers out in front. And I can factor this, or again use the general quadratic equation to solve this. And I get two solutions when x equals 1 and x equals negative 2. Okay, just one trick, or one thing to consider here. You do have to have real x values to have those intercepts actually cross the x-axis. Okay, so it is possible to end up with imaginary numbers here, but what that tells you is that your graph actually never crosses the y-axis. Okay, so maybe it's all above the x-axis. It's all above the x-axis, or it's all below the x-axis. That is possible. Okay, and in which case this isn't a very useful method of solving this, but it is nice to kind of know. So just something to keep in mind. Okay, so now let's put this all together. We've got 3 points now. Our first point is from finding the vertex. Our x equals negative 1/2, y equals 9/4. Our next point is where we cross the x-axis at point x equals 1, y equals 0, and the next one at negative 2, y equals 0. All right, so here's our plot, or here's our graph. Let's plug in those values. Here's the vertex at negative 1/2 and 9/4, and here's our two y-intercept values, or x-intercept values. I'm sorry. At negative 2, 0, and 1, 0. And let's just draw the lines that connect them here. Okay. So again, we could plug in more and more values to see this, but this is one way of doing it. So it's nice to connect what we did at the beginning in the first couple of videos with this. So this is, there's how you solve them, and here's how you can plug in those values, especially if you've already gone through the work of finding the roots of the equation or something like that. Okay. So that's how you graph these. Fairly straightforward. But, at the beginning you may want to just make sure you're plugging in numbers until you get more familiar with these equations. Okay? Good luck on this week's homework, and I'll see you in class.